A very good afternoon, everybody. Thank you for joining us for the FutureSkills Prime Career Mantra session on 5G and beyond, building connections of tomorrow. Hi, Raj. Just a quick check. I hope you can hear and see me well.
Yes, Amrita, thank you.
Thank you so much. During this session, you may share your questions in the Q&A functionality of the platform. My name is Amrita from FutureSkills Prime, the National Digital Skilling Platform, which is a joint initiative of Ministry of Information Technology and Electronics, along with NASCO. With the recent progress in the 5G spectrum auctioning, the telecom and the IT industries are waiting for a revolution. With enhanced 5G connectivity, there will be a rise in applications enabling immense user experience and smarter technology. Today, we are going to find ways to make 5G work for us. This session is our chance to understand the technical requirements behind the designing, deployment, and maintenance of 5G technology. So without further ado, please join me in welcoming our experts. We have with us Raj, who is a business consultant in emerging technologies. He is the leading senior level strategic sales and global business consultant in emerging IT ecosystem. Raj is considered a subject matter expert in relationship building, creating sustainable IT solutions and doing business in North America, EU, and the APAC. He closely tracks industry foresights in AI, ML, 5G, cybersecurity, and the list is much longer. Then we have Dr. Manikanthan Srinivas, Money for Us. He is an industry experience. He has an experience over 20 years in the domains of network and network security. At NECI, Dr. Manikanthan is involved in 5G and beyond related research, ORAN Alliance architecture-based 5G solution development, 3GPP, and telecom security standardization initiatives. He is also an adjunct faculty member at IIT Madras, specializing in networking, network security, and advanced wireless communications and network. Finally, last but not the least, we have Mr. Anton Basil, Associate VP Technology at Alton Calsoft Labs. Highly accomplished and goal-oriented individual that Mr. Anton Basil is. He is an engineering technocrat with over 28 years of telecom and datacom experience in various areas such as R&D, product development, product management, standard body contributions, open source software adoption, skill development, pre-sales, and solutioning. Welcome, everybody. Thank you for joining us today. Over to you, Raj.
Thanks, Amrita. Let me go to the screen share and oh, shoot. Sorry, guys. Let me start this by saying that this is going to be on 5G and beyond and building connections for tomorrow, right? Let me qualify that 5G and beyond is an ocean, and therefore we all need to navigate very carefully through it. And we will try to run you through as much information as we can share for creating an awareness, including touching points on technology, which Anton and Mani will be more adept at. I would be more on the business side and the market needs situation side of the story. The agenda, we are broadly covering the introduction, market projections, general perspective, evolution, the technical overview and NEC, AI, ML and its relevance, security, and upskilling opportunities in the 5G arena. Getting to the introduction, I would like to highlight the market, which is growing at a 66% CAGR in here from about a single-digit billion to $800 billion in a span of just 7-8 years. So you can see the opportunities that are around given the market requirements out there. Giving you a backdrop of where this all started. And therefore, the 3GPP cellular network standards generation timeline, while this is very detailed, I'm going to touch on the first bullet. In 2004, NTT Docomo of Japan proposed the LTE as the international standards, and then it came into being, right? So that is back in 2004. We are now in 2022. So you can see the amount of contribution from technology, the market, and professionals that has grown in here. And this is only taking you up to 2011, where Sri Lanka was the first to establish a 4G LTE in South Asia, achieving a 96 megabits rate. I'm not running through each of the bullets, but this is a snapshot view for you guys, giving you a general perspective of the long-term evolution, how it has come about, right? It's a standard for wireless broadband communications, mobile devices, data terminals, which used to be based on GSM Edge and UMTS and HSPA standards. Now, what improves these standards capacity is using the radio interface. LTE provides an upgrade path for carriers with both GSM UMTS networks and the CDMA 2000 networks, right? Now, different countries use different frequencies and bands, right? And therefore, only multi-band phones can use technologies wherever it is supported. This is something to be noted. The standard, the third generation partnership project is the one that necessarily defines the standards that are being followed in here. And they started with release 8 and release 9 back in time. We will come back to why it is still called 3.95G instead of 4G, but getting marketed as 4G LTE and advanced 4G, right? That certain technical criteria and specifications of the release 8 and 9 document that had to be met, and therefore the 3.95G as a word appears there. The requirements were set forth again. Now, if you move forward, you see ITU organization and the IMT advanced specifications define this. And then with advances that WiMAX and EHSPA had, the original 3G technologies to the enhancements to the original 3G technologies, ITU later decided that LTE and the aforementioned technologies be called as 4G, right? So 3.95 is more from a technology standpoint, but from a marketing standpoint, it's getting more termed as a 4G. And obviously, how it supports, like I mentioned earlier on, the first standards were proposed in 2004 by Japan's NTT Docomo. Here, I would like to take you guys to showcase LTE Network on the Moon, a Nokia NASA collaboration and Intuitive Machines collaboration. So I'm going to play this video for you guys and let us see how we can get there.
Why do you need a cell phone tower on the moon? Why do you need a cell phone on the moon? The reality is that the systems that we typically use in aerospace have very low amount of data that you can send back and forth between a spacecraft and the Earth or a spacecraft and another spacecraft. LTE offers a different technology that did not exist in that marketplace. And so this test for us allows us to get a much higher bandwidth of data.
Our goal is to deliver a fully integrated, very compact LTE network that has multiple parts to it. There is a part that is the base station and core network functionality that's integrated in a very small, compact form factor that will go on the lunar lander that Intuitive Machines, our partner for this mission, is building. And so our LTE network equipment will go on the lunar lander. If you look at some of the extreme industrial environments, whether it's mining operations or you think about offshore drilling platforms, I think in any of these harsh environments or you're remote and the equipment has to operate in very different environmental conditions, whether it's temperature, humidity, dust, exposure to all kinds of environmental particles and so forth. I think mining, offshore drilling, very remote areas, I think that's where probably the equipment is most applicable, and also environments where you're space and size constrained. If we can solve problems to put a network on the moon and have it operate on the moon, we can solve any problem on Earth. And if I can build a network that operates on the moon, I can build a network that works in any environment for our CSP and enterprise customers.
Guys, that was a video or presentation that I did want you guys to see. And now we go to the next chart where we are essentially talking about, oh, shoot. Sorry, guys.
Space telescope is, in a way, a little like Galileo's first.
So if you see the coverage, which was the LT coverage across the world that was marked in March 2019, you will see that there are 10 countries that appear in here. What I'm proud about is India happens to be number 10 in there. So it was very much in there back in 2019 when we're talking of the 4G LT coverage area with a 90.9% coverage. Obviously, you see that United States itself was at number 5, which is a very interesting observation. But well, I think we have done a lot more progress and we will continue to do that. Giving you a perspective of 5G, what is 5G, right? It's next generation cellular technology, which is going to provide high speed, reliable communication and ultra low latency levels. This is a very interesting requirement going forward. Low power requirements also come in and play. It covers the entire ecosystem, right? The hardware, the software services, and the critical that are critical for implementation of 5G networks. And the technology market includes 5G connectivity, that is enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. 5G is expected to redefine communication, entertainment, and how that market is progressing. I mean, you talk of gaming and so on and so forth. There's a lot of people who are subscribing to that. Now, the frequencies that 5G is operating right now is ranging from 24 to 100 gigahertz that facilitates faster data transmission. And here is what is a view of what makes 5G different and what Ericsson has to say about it. So I'm going to play this video for you guys.
We're creating something that will shift the way you look at the world. Technologies and 5G networks powering the next chapter in innovation. For communities, for economies, for the climate. This changes everything. When lights, signs, and cars are all talking, you'll know what's happening. Not just around you, but 5 blocks ahead. Don't stop. Go forward. It's the flow of the city. Go out into the world. Explore. Experience in new ways. Dive underwater or travel through space. Do what you want. You're no longer running blind into a difficult situation. I see robots helping us out. Get the clear picture from a safe distance. On another level, 5G brings power to our industries. Produce smarter, make conscious adjustments, and keep improving. We create technologies that let you view the world in a new light. Let's explore the 5G technology.
That's what Ericsson is talking about when they're talking about the 5G technologies. Shoot, what happened here? Oops. All right. There are a couple more videos that we will be taking you guys through as we move on. So let me go to the next chart in here, where we are talking about the 3GPP releases and 5G. This is courtesy Qualcomm as to how they have presented it. What happened in release 16, right? It was essentially establishing the foundation where you're talking of an accuracy of 3 meters to 10 meters for indoor outdoor at an 80% availability of time, right? And supporting RTT, AOA and AOD, TDOA, single cell positioning. What happens in release 17, and we will cover this more in detail going forward, right? But here we are moving to the centimeter level accuracy. As you can see, for commercial cases, it's getting to less than 1 meter, and for IIoT, less than 0.2, within 100 millisecond time span. So the low latency also gets achieved in here, which is going forward, talking about reduced positioning and latency. Then we are also talking about improved efficiency and the GNSS enhancements, which essentially takes care of your global SATCOM satellite network system, and how the BDS also gets explained in here and implemented. As a matter of fact, release 18 is yet to begin. It's actually the work has just started this quarter, if you will, and we will come to release 18 subsequently. But what is it in 5G release 17, which just got firmed up, right? June last month, right? It's not the 17th release. It's the third release for 5G. It's called release 17. That's all right. Now, release 16 was up to 52.6 gigahertz, where release 17 grasps the entire range, and from 60 gigahertz going up to 71 gigahertz, right? What is this helping us? Specific enhancements are reduced capacity, the RedCap, the new radio network light, the non-terrestrial networks, the NTN network connectivity through satellites, millimeter wave expansion, topology expansion. We are getting, you have to also therefore see why and how 5G is better, right? In 3G, we had one receiving antenna, 4G, 2. In 5G, we go to 4 receiving antennas. Now, the 5G new radio, it's a reduced signaling overhead, which is important. Low transmit power, which is again important. Narrower bandwidth and repetition and order modulation, the side links or relays, and we will talk about side links a little more going forward. Now, for the 5G NR, the non-terrestrial network in undeserved areas, and I'll give examples going forward as to how this has been actually covered, and the plans for 5G. LTE 4G has already been deployed. 5G is getting deployed in Amazon forest. We'll come back to that. What are these centimeter level accuracies as opposed to 3 to 10 meters that we talked about earlier, getting down, right? And the optimization that comes up. So these are some of the benefits of the 5G release 17, which just got firmed up. And since the last point talked about the XR, here I'm going to play a video for you guys, which again you will find interesting.
Video game is fun. Being inside the action is so much better. That's why virtual reality, VR, is poised to become the biggest technology phenomenon since the smartphone. AT&T and Warner Brothers teamed up with Ericsson, Qualcomm, Dreamscape Immersive, NVIDIA, and Weaver to demonstrate an industry-first 5G-enabled multi-user immersive location-based VR experience. It takes place in the fictional world of Harry Potter Chaos at Hogwarts.
We do think network connectivity has, real possibilities. The combination of the 5G, the edge networking, and fiber almost feels like this dream team of technologies that are going to allow new and incredible things to happen.
Sorry guys, bandwidth situation. Guess we do need 5G networks as of yesterday.
Raj, can we continue with the presentation? Maybe we can share the link of the video with the viewers on the chat.
I think so, because yeah, I think that's a better idea. So we move forward. Well, as I mentioned before, I'm giving you guys an overview of what all encompasses 5G, and therefore we are not ignoring the role that artificial intelligence will play in the 5G future, right? And how are 5G and AI connected, right? What kind of intelligence AI as well as ML bring in when we are talking about operating in the 5G space. How does 5G play a role in the edge computing side of the story, where you have smart devices resulting in exponential growth of data at the edge? We have not ignored how artificial intelligence is helping future 5G networks in India, right? I mean, we are not just looking at global markets and ignoring the large requirements that our country, India, has, right? And here again, the 5G networks combined with AI make the network better, more intelligent, and offer more enhanced services. We will have a detailed section on that taken by Money going forward. I'm just giving you, like I said, a snapshot of this. The other element that we cannot ignore is how satellite communication is going to play a role as a backhaul for enabling 5G deployments, right? You already have Amazon Cooper, Verizon has conducted trials with it. Ericsson, Thales, and Qualcomm, they want to take 5G into space. Nokia and NASA collaboration is for deploying 5G network on the moon. And the earlier presentation, Thierry Klein's presentation that you saw, he heads this chapter for Nokia. They're going to start with the LTE, and testing is going on for 5G stability to adapt to the lunar ambient conditions. I talked about Amazon forests earlier to you. Ericsson with Telefónica's subsidiary had actually deployed the LTE network in the Amazon rainforest, right? And now they have plans to deploy the 5G network in the Amazon rainforest, again, using the satellite communication technology. Not to ignore TRI. TRI has recommended provisioning of cellular backhaul connectivity via satellite. This is absolutely India-centric, and therefore we are absolutely on par with what's going on in the technology evolution. Talk about Elon Musk's SpaceX program, right? Over 1,000 satellites orbiting and offering broadband connectivity in over 32 countries. Not to forget HughesNet, Viasat, and a lot more satellite providers who are out there to offer the same backhaul connectivity for deploying 5G networks. Amrita, could you pop up poll question 1, please?
Sure. Here comes the poll.
You want me to stop sharing, or you can do that without that?
All good. We can do this. The first question is
right.
going to. Can you see?
Yep.
So we have 60% participation. Should I stop the poll now, Raj?
Excellent. Do we have the statistics for questions, or should I go back to the presentation? All right, thanks. Wonderful. So home society will and smart and all right, that gets the majority, 57%. People enjoying sporting events is 8. Optimal solutions for manufacturing, industry 4.0 and stuff, 25%. Roads can be safe with autonomous vehicles. Yeah, I guess India has a distance to go in there, but we will get there faster. All right, thanks, appreciate it. All right, I go back to sharing. What's going on? All right. There are a couple other elements that I wanted to attract your attention to when we're going to talk about upskilling, right? I don't know how many of you have heard about Magma, but Magma is an open source software platform that is providing the network operators a very flexible and extendable mobile core network, right? Why does it offer better connectivity? You know, because it does not have a vendor lock-in, for example. It enables operators to manage their networks more efficiently with a lower downtime, better predictability, and more agility to add new services. Then the federation between existing MNOs and new infrastructure providers is helping them expand in the rural infrastructure. So these are some of the benefits, and you know, whoever would like to understand Magma should go on magma.org and do their research further. There's another chart that I'm going to bring up, and I'm going to request my colleague Anton to elaborate more on that. Anton, could you take over, please?
Yeah, thanks, Rajesh. So as Raj communicated, Magma is a open source software that is available for anyone who wants to implement the 5G network, may it be a private network or public network. So basically it has 3 components. The main component that provides the network services is called access gateway, where you can provision the network services and offer these services to the end customers. And then you have a second component called orchestrator, through which you can provision the access gateway whichever way we want to. For example, you can set the policies, you can set the configurations for the network, the mobile core, or if you want to set the access list, all those things can be done using the orchestrator. So this is, for example, the third bullet point, what Rajesh said is it can be done in a rural area. So you can create your own mobile network for a rural area or the places which is hard to reach. But if you want to get connected to the MNO, the mobile network operator, it can be done. So they have a third component called federated gateway, where you can connect your network to the mobile operator so that all the pricing plans, the policy configurations, and everything can be downloaded from the mobile network operator, and it can work in tandem with the mobile network operator. So this is the concept of Magma, so which is primarily done for the private mobile cores, but it can also connect to the public MNOs. Over to you, Rajesh.
Why is it not scrolling to the next chart? All right. To give you a perspective of Magma, right? I mean, let's take the tier 1 meta connectivity, right? Which is contributing a major contributor to the Magma as an evolved packet core network, right? And it enables the CSPs to deliver a faster internet connectivity and innovate features with a robust open source community of developers, right? What is the strength? It's not just an open source platform, but it is also vendor hardware agnostic and network agnostic. Now, this is what gives the CSPs a extraordinary capacity, just like Anton mentioned, to go and have 5G deployments in hard to reach areas. Here, we are not necessarily using satellite at all, right? It's happening without that. And the smaller footprint of the access gateway, which means it can run with a minimal edge server in the eNode B situation. So these are some of the benefits of Magma, which is gaining a lot of traction. From an opportunity perspective, I'm not sure how many of you are aware, but I know of at least two companies, Indian companies. Actually, one is an Indian company, other is incorporated in the US, but has majority of developments happening in India. One is, I think, LNT, and the other is the startup, which is Wave Labs, right? So Wave Labs and LNT, apart from multiple other partners that Meta have embarked on the Magma path. So opportunities are huge. You guys need to do your homework and decide what area you want to go forward with. Likewise, I would like to talk a little bit about Golang. Go language is nothing but that's come out from Google, right? Why is it widely used in DevOps and cloud native space? And what are the why is Golang excellent, right? The concurrency, garbage collection, multi-platform availability, security, and ease of compilation. Right? How do you achieve this, right? I mean, you have the Go routines and channels that help in DevOps, for example. Then you have the Vice system, DevOps, and cloud native tools are written in Go, right? This is also a good question that we need to understand, right? Several DevOps tools have been written in Go. As you can see, I've given you about 12 examples here. The Prometheus, Grafana, Terraform, CockroachDB. Yeah, I'm not reading all of them, but you can see the traction that Go is gaining as we move forward. Even Docker is written in Go. You talk of Kubernetes. Kubernetes is nothing but what is Kubernetes? It's a container cluster management system, right? And why are they using Go for it? Because of the same features. Now, if you take a comparison between Python, everybody talks about Python today, right? Versus Golang, you can see Golang is 40 times the speed of Python. Again, Golang compiles directly to the machine code compared to other programming languages needing to go to the object code and so on. So once again, Golang has certain significant benefits because of which it is gaining traction. And therefore, this is another area when we go to the upskilling side of it that you folks may want to consider. There is a very different element that I'm going to talk of here. I don't know how many of you have heard of Rust, probably many of you may have. But why stuff? It offers you the memory safety, the memory management, the polymorphism that takes place in there, the trait objects, and the macros for language extensions, and seamless interfacing with C++. There is a thought that C++ may get replaced completely with Rust. And a lot of companies are specifically embarking on using Rust specifically for high compute performance applications. And how are these going to be utilized in the 5G ecosystem is what will decide the amount of traction that Rust will gather going forward when you're considering options for upskilling, right? Not to forget, cybersecurity. Security is a concern, and it only increases as we increase the bandwidth, the speed, the low latency, and stuff like that. So here is the White House zero trust strategy, right? Zero trust strategy works the best for 5G from a security. Money will be covering this in more details going forward. But if you look at the 5G White House zero trust strategy, what it's talking about is providing against phishing attacks, track and monitor all devices, encryption of all network traffic, and secure online access, and automation of detection and blocking unauthorized access to sensitive information. So these are the 5 charters that they have taken that by the end of the fiscal 2024, we need to achieve, right? So that we make it a very secure network to work about. Talking about upskilling, right now, over 2 million people are not found and are required. And there are 53% companies complaining for the lack of cybersecurity professionals, which are absolutely a must-have. Just giving you a sense of the opportunities out there when you're considering your options for upskilling that you will need to tick on which ones you want to take up. All right, let's also talk about what has 5G achieved so far. Well, 10 to 100x improvement over 4G and 4.5G networks, 5 nines availability, the 8 specification requirement, 1 millisecond latency, 100% coverage, 90% reduction in network energy usage, 1000x bandwidth per area. So 5G is a requirement. And I will drive your attention to two words going towards the end of the presentation as to how we need to move forward in a conscious way of the technology evolution. So these are the upskilling opportunities in the 5G space. And I'm giving you an overview. We will be touching in more detail on the upskilling opportunities and various sort of resources that you may want to look at. When you look at the core network, the cybersecurity we talked of, you cannot ignore test automation and validation, ambient conditions and performance. As I said, we saw the video on LTE network on the moon from Nokia. They just set up a huge test lab in Dallas, Texas, for doing test validation to ensure the 5G network will adjust to the ambient conditions on the moon. So their plan between Nokia and NASA is to deploy a 5G network on the moon. They're starting with LTE 4G right now. You obviously cannot ignore NPOD, right? And we will talk more in details on network planning, optimization, deployment. We talked about Magma, AI, ML, Money will be covering it in more details. Satellite networks as a backhaul, it's a very interesting area. Not sure what your awareness levels are in here, but this is going to play a huge role going forward, trust me. Even including India. We don't have to go to Amazon rainforest for that. I mean, you go, even in metro cities today, we have connectivity issues with the 4G, right? So therefore, how they try dictate is going to help improve connectivity even in India. Obviously, 5G deployment for edge subscribers is going to play a very, very big role because, you know, the human mind, you get one, you want 100, you get 100, you want 1,000. It's always increasing in 10x folds, right? Amrita mentioned about the 5G auction that recently happened in India. I'm not sure how many of you are aware, but if I am correct, L&T, PS, and Tata's have won the auction for 5G private network deployment in India. Therefore, this is another very interesting area of opportunity. We talked about Golang and Rust, and therefore we move to poll question 2. I hand it back to you, Amrita.
Hi, audience. This is Mani here. So in this poll, we want your opinion in terms of what you consider as the greatest benefit of 5G that would provide to the entire community. Is it faster access, or is it going to give an increased capacity, or is it going to enable more network coverage, or there will be lesser network issues? Please share your opinion against these 4 points, and we would um, indicate your response and what the exact situation is. Thank you. Okay, so in the poll, you have given a verdict that it gives you a faster access. 53% of you said faster access, and then the next highest goes for better network coverage, and then increased capacity and less network issues. Yes, certainly the 5G would give you increased faster access as well as capacity and better network coverage. Issues that arises due to coverages, etc., will get reduced, and ability to get it in shorter time will be addressed as well. Thank you for your feedback. Over to you, Raj.
Thanks, Mani. We move to the next chart here. Oh, shoot. Here, I would like to invite Anton. Let me also talk a little bit about who the three of us are. Me, Anton, and Mani have known each other for 3 decades. We've been ex-colleagues. The reason why I wanted to specifically bring this comment at this point in time was I wanted to highlight the way Mani and Anton have upskilled themselves over the last 3 decades today to be called the 5G network technology stalwarts. This is a live example. You are listening to them here. I would like you to take some excitement from them and then decide the areas you want to upskill yourself on. Over to you, Anton.
Thanks, Rajesh. So from now on, I'm going to give a high level or deeper dive into the 5G networks. So before we get into 5G networks, I want each one of you to understand what a typical mobile network consists of. So basically, it will have a radio access network, which will cover the towers, the E-Node Bs, the user equipments. It could be a mobile phone, a pad, or whatever it is, and it has a backhaul the network, which consists of all the RAN components, the baseband units, the HLRs, MSS, BSC, MSC. So all those things put together will form the radio access network. And then this radio access networks will get connected to the mobile core. The mobile core could be a 3G mobile core, 4G mobile core, or 5G. So whatever it is, it will get connected to the mobile core. From the mobile core, it gets into the data network, which means getting into the internet. Okay, this is the overall architecture of the mobile. The towers, the E-Node Bs, the UEs, and the backhaul network put together, it is called RAN, radio access network. Radio access network along with the mobile core will be called the cellular access network. So this understanding has to be very clear because this is very, very important for me to go through the next set of slides. The next slide, we are going to, Raj, next one. The next slide, okay, we are going to talk about what are the real drivers that has really pushed us to get into 5G. Okay, as you all know, right? We have come to a world, even with the LTE 4G, we want internet everywhere, right? Wherever we go. When you are sitting in the building, you do your browsing, you do so many things when you are sitting in the house or in an office. When you walk, okay, you are going to book a taxi, or if you want to see, want to go to a particular location using maps, or when you are driving, you want to go to a particular destination, you use internet. Okay, on a high speed, transportation. Again, you want to see, how far is this location from there. So wherever you are, you want the internet to be there with you always. So we have got into that habit. Okay, that is one of the drivers. The other one is with the evolution of this Internet of Things. Okay, wherever the device that can collect the data would like to get connected to the cloud, and it wants to exchange data. So everything is connected with everything else, and this data has to reach the destination from the source faster. It should be reliable. There should not be any disturbances in that data transfer. So that has really pushed us to create a reliable, a high speed or faster network, and that can provide a huge bandwidth, the capacity. So these are the primary two drivers that has really pushed us into the 5G. So from now on, let's see the from the drivers point of view. Let's look at what are the different objectives. It is very clearly higher throughput. And people keep saying different numbers there. Now we have reached 1 gigabyte, 10 gigabytes, 20 gigabytes. So as of now, we have reached 1 gigabyte and we are aiming towards 10 gigabytes. But what I put here is the peak data. So it may not be consistently providing that data, but a peak data of 20 gigabits per second is the one of the objective. The second one is, like I said, right? So there are several things which are getting connected. So if you want to communicate some information, the critical information, then it has to have a lower latency. It has to reach the other side much, much lesser than 1 millisecond. So the ultra low latency is the second objective. The third one is for IoT, Okay, the 5G has to provide a space. We want multiple devices to get connected to the the backhaul 5G network. So it should be able to handle multiple devices together. The current network 3G or 4G cannot take that much of load. So the 5G has been fine-tuned to handle multiple devices. So if you look at this chart, we'll talk about 100 times what it is doing now. So it should be able to handle that much of end devices. And the next one is uniform experience. Okay, so for example, there are multiple people using the 5G network. Okay, the experiences faced by all the three people should be same. There shouldn't be any difference. For example, the data from the one user cannot exceed the other. So we want to give a uniform experience for the end users. The second one is efficiency of the energy. Basically, right? The moment you have a small device, a sensor in your house, getting connected to the cloud using 5G network, for example, right? So we keep charging our mobile every one day at least, every day we keep charging our mobiles. And that should not be the case with the IoT devices, small sensor devices. We should not keep charging. So it has to go multiple months, at least 6 months, 3 months, 1 year, it has to go. So the signaling, the signaling that it uses to get connected to the radio network should be done in such a way. So basically it should be narrow band. It cannot be broadband. So it should be done in a narrow band. So your battery is not exhausted. The last one is, okay, we keep talking about so many things. Until 4G or LTE, we never talked about the service-based architecture, the microservices architecture. With the 5G, they wanted to bring all the functionality as a service. If you want to talk to one functionality, wants to talk to another functionality, so it has to be defined as service. And it has to talk in a way such that the communication is like subscription, and you keep accessing that service. So that kind of communication has to be established. So 5G is the first mobile core that is developed based on the services-based architecture, basically, the microservices-based architecture. So these are the key objectives. There are several other objectives, but at least I want to capture the key objectives here. The next slide, Raj. Okay, let's get into the use cases. I think this was briefly touched by Raj as well. He talked about the EMBB, basically enhanced mobile broadband. I talked about massive machine type communication and ultra low latency. Okay, these are the major 3 use cases that are defined by the standard bodies. But the implementers are actually defining more and more use cases. So beyond this. Okay, so when you look at the enhanced mobile broadband, it is like instead of using my modems, getting connected to the network, you can always use the wireless. So that's what we call it as fixed wireless access, FWA. The second one is, right, you can use, you are using high definition TVs and you can connect it to the internet, right? And you want to see a jitter-free experience on the TV, right? So even for that, you need a higher capacity, the broadband connectivity or backhaul connectivity, so that you see your experience is really very good. Okay, so that comes under the enhanced broadband, mobile broadband. The second one is called massive machine type communication. So this is primarily for, I was talking about with the evolution of the small IoT devices, sensors, actuators, so many things, right? So there'll be a lot of communication. The data coming from these devices may not be huge. It cannot be in multiple bytes. These are very, very small packets, but it comes in a faster, with lesser gap in between. So lot of packets, smaller packets coming from this. It can come from several devices. For example, if you have certain X number of devices connected to the 5G network, now it will be 100 times that. So many devices will get connected. So where are they deployed? In the smart buildings, where they want to know for security reasons, they want to monitor what is happening in the building, right from your electricity, your gas, your water. Okay, it can be used in the smart cities. It can be used in the industrial environment. Okay, several such places where the small sensors and actuators will be used, and it will get the data, push it to the cloud for the further analysis. So that kind of situations will need the massive machine type communications. The last one is the ultra reliable low latency, where it is a critical stuff. Like for example, you can talk about healthcare, you can talk about the gaming, AR, VR, where the response time is very, very critical. The moment you give a request, you want the response back within short span of time. So in those kind of situations, we keep using the ultra low latency communication, where the latency is the key, the jitter is the key. The moment I give the request, how fast I get the response back. So these are three different kinds of use cases for which we are trying to evolve, we are trying to bring up this 5G network. Next slide, Raj. Okay.
Can you pull up a pop-up poll question 3, please?
Hello, audience. We need your thought process on this poll. As what do you think about the 5G use case that would be adopted first? In your opinion, would it be for fixed wireless access or smart city, or for automation of the industrial functionalities or autonomous vehicles? So once you finish the poll, Anton will analyze your results and then continue further. Thank you for your feedback.
Yeah, so the poll result states that 47% of them feels the fixed wireless access will come first, followed by smart city. This 37% feel smart cities will be, people, 37% of the participants feel that smart city will come first. Industrial automation and autonomous vehicles is more or less same, 7 and 9%. Okay, thank you for your feedback. Raj, next slide, please. Raj, next slide, please. Okay.
Yeah, sorry guys, apologies. I think we need 5G, 6G right now. The network is playing tricks. Apologies for that. Okay. Go ahead, okay. Take over.
So now that initially we talked about the cellular network at a higher level, now we are going to get into the 5G, landscape. Okay, I talked about several things, what 5G is supposed to offer us. One of the key things, okay, that 5G has given us is it supports multiple RAT. Basically, RAT is radio access technologies. You can connect a Wi-Fi into the 5G network. You can connect a broadband into 5G network. You can connect the satellite network with 5G networks. That is one of the key advantages of that. If you look at this landscape, okay, a mobile getting connected to the tower, it gets connected to the 5G core network. A mobile going through the Wi-Fi device, even that can get connected to the mobile network. Okay, even on Wi-Fi, there are two different kinds of interfaces. One, it's a trusted Wi-Fi interface through which you can connect, or you can be traveling, you can be sitting somewhere, you can get connected to a untrusted, okay, Wi-Fi connection to the core network. So what do you need there? Like you have the towers for a regular 5G connectivity, you need to have an interworking function. So basically, it has to convert that Wi-Fi in the manner which is similar to your RAN network, and it has to get connected to the core network. So that is why you have several interworking functionalities there, right? N3, you have N3, we have it's a non-3GPP connectivity, a trusted WLAN interface getting connected, or trusted non-3GPP connectivity. Okay, I want to slightly touch upon this. What is this 3GPP, non-3GPP connectivity, right? So you may be thinking, I just keep on talking so many things. For example, as per the 3GPP standard, they have basically allowed 3 different kind of connections. So one is the UTRAN connection, basically the 2G connectivity. Then they have allowed the 3G connectivity, what we called as GRAN, GPRS RAN, and 4G. It is EUTRAN, evolved UTRAN. Okay, these are the UTRAN is universal terrestrial RAN, radio access network. So these 3 connectivities are allowed by 3GPP. Then what are we talking about non-3GPP here? Okay, so this will primarily cover the WLAN, the CDMA, the fixed network, getting connected, the satellite network. So all these are 3GPP connectivity. So the 5G core network allows both 3GPP connectivity as well as 3GPP, non-3GPP connectivity, and it has ability to handle that. So it will be able to support wide range of people, subscribers into its fold. Okay, that's what I want to touch upon on this particular slide. Next one, Raj. Okay, so we talk about so many things now. 5G is good, the 5G landscape is like this, all this stuff. There are so many technologies. I don't want to touch everything and then keep boring you. Okay, so basically some of the key things, right? Like even Raj, touched upon, like number of radios that has been put on the towers, that has been increased. Okay, the kind of radios, the 5G itself is called new radio, NR, which have larger capacity in terms of to provide a wide band to support different kinds of higher capacity, low latency, all those stuff. And it has a beamforming capacity. The microwave, it can be directed to an individual user rather than just spreading it in the environment, into the air. So that is one of the capability. It has a reliable backhaul connectivity. So it has redundant support in the backhaul. It has highly reliable backhaul connectivity. It has multi-hop connectivity in the backhaul side. It is very low latency, which means it is able to provide faster response times. It supports massive MIMO. So these are different technologies that helps us to literally provide a new level of capability for this 5G network. So what are we going to achieve? So basically 10x of throughput, and it has reduction of 10x times reduction in the latency. It has 10x connection density, which means it can support so many connections. So it has the spectral efficiency of 3 times, and it can support I was talking about the multiple devices getting connected, so 100 times more devices can be connected. So there's so many advantages. So these technologies really help 5G to provide a better connectivity, better support, the different types of, it can support different types of devices, faster communication, quick response times, okay, highly reliable, right? And then less interference. So many such things we get out of 5G due to these technologies. Next slide, Raj. Okay, so here we talk about the scalable design, right? So here I'm going to talk about a little bit on the the carrier spacing. For example, you can have outdoor access connecting to the tower. You have outdoor small cell access. Basically, you have these devices getting connected to your lamppost in the streets, and then that will get connected to the tower. And you have indoor, and you have wave. The thing is, the carriers have been split in such a way that it can be scaled. It will be, for example, for the outdoor, the carrier spacing is 15 giga kilohertz, and you can scale it. You can increase it in terms of that. For example, the outdoor, it has a 30 kilohertz spacing that can be scaled. For example, the indoor, for example, the outdoor thing, okay, the capacity may be less. but in the indoor where you can increase the capacity. So the carrier spacing is in the 60 kilohertz range, the wave. So it gives high speed. So where the carrier spacing is 128 kilohertz, but it cannot go to the longer distance. So it provides a different range of the spectrum, which can be scaled up, scaled down, whichever way you want to do it. So that's an advantage on the radio side. That's an improvement on the radio side. Next slide, Raj. Okay, RAN architecture. So I talked at a very high level. Here, the RAN consists of a UE, which is getting connected to a RAN network, right? The E node B, right? So the E node B getting connected to the backhaul connectivity. So now let's get a little bit deep into that. What will the RAN consist of? A UE has to get connected to the, here it is called RRH. We also normally used to call it RU, the radio unit. So basically it has to get connected to the RRH. RRH is remote radio head. That will get connected to the DU. DU is called distributed units. Okay, I will talk about that a little bit deeper. Okay, and then these DUs can be connected to CUs, the control units. Even in the control units, there's a two different split, the control plane and the user plane, right? And this will get connected to the core network, right? So what will have? Now it has a set of protocol stacks. So it has a physical layer, it has a MAC layer, it has a RLC layer, PDCP layer, SDAP layer, RRC layer. So the DU, as per there are several splits. They have split the protocol stacks. You have a lot of split 2, split 8, split 7.2. Just due to time constraint, I'm just touching upon the split 7.2, where you will have the radio remote head, and your DU will have the physical layer and the lower MAC layer. The CU will have the remaining stack, right from PDCP, SDAP, from RLC to RRC. All those things will be part of your CU unit, and this will get connected to your core network. Next slide, Raj. Sorry guys, due to time constraint, I have to rush up a few things. So if you need any clarification, please put your questions in the Q&A. I'll be happy to answer that. Okay, now let's get into the 5G core. The key component in the 5G core is called AMF, the access and mobility management. So that's the entry point into the core network. The RAN will get connected there, and this will get further connected to the SMF, session management module, and then it will be configuring the UPF, that is user plane function. So these are the very key modules here in the core network. Okay, here, as I told you before, all these were based on the microservices architecture. What does it mean? Every module here will run as a service, and it will register itself that this service is up and running, and it will register with a centralized module. Even the centralized module, what we call as NRF, the network repository function, okay, that will also run as a service. The data that is stored, the UDM, Unified Data Management, even that will be running as a service. The data, the centralized, the control functions, all the 5G network functions, everything will run as a service over a common message bus. You can be gRPC, or you can have a Kafka bus, any bus for that matter. It will run over the bus, and it will communicate using the remote procedural calls. So here, there's a control plane, which primarily has AMF, SMS, and all the other modules, the authentication function, AESF, the policy control functions, PCF. You have the NEF, the network exposure functions, it can expose to the higher layers. So those things will come under the control plane. Okay, the data ones, the UDR and UDSF will come as the storage plane, and you have the user plane or the data plane where you have the UPF running. So you have to get connected to the control plane first, get your connection established. That will provision the user plane or data plane, and your data will flow through the user plane. And all these things will be running as a service. Next slide, Raj. Okay, here I'm going to talk about the end-to-end architecture where, the split I was talking about. This is 7.2 split. You have to come from left to right, where you have, the DUs on the left, the CUs next, and then you have the 5G core. Just to give a end-to-end architecture of the 5G, and you'll be puzzled. There is something running on the top. I never talked about it. You'll be thinking, what is this something on the top? So which I'm going to cover in the next slide. Next slide, Raj. This is called the ORAN stuff. Okay. So on the ORAN side, was actually defined by the Oral Alliance. See, basically, they want to build a open, intelligent network management capability to the 5G for the RAN. So they develop different interfaces. So the moment you say open, so they want to have all the modules. For example, I've given DU, CU here. They want to make it open. How do you make it open? The API has to be standardized. Who is going to standardize the API? ORAN Alliance has to going to standardize the APIs. So the DU that provides support for CU, all the APIs will be standardized. The CU that provides the interface to the management layer, that will be standardized. Then you have the management interface, which is going to talk to CU or DU. We'll have a standardized interface. So everything is standardized here, right? So the ORAN Alliance want to make it open, which means any vendor module can talk to any other vendor module because it is standardized. Second, they want to bring in intelligence. For example, if there is a degradation in the communication, so they want to build some intelligent components within the ORAN. So that is why they developed the core part of that ORAN architecture is RIC, Radio Intelligent Controller. Even there, they define two different kinds of RIC. One is real-time RIC and then non-real-time RIC. The real-time RIC keep talking to all the modules, the DUs, CUs, radio units, and make the necessary adjustments so that the end user experience was not affected. Okay, it can either reduce the noise interference, it can load balance, okay, it can shut down certain things, bring up certain modules. So that way, right, it want to make the 5G network reliable and having a faster and having a excellent user experience. So that's why the ORAN Alliance has really come out with the ORAN architecture. So I can talk hours together on this, but due to time constraint, I've just restricted myself to this, where there is a DU, there's a CU, there's a management entity, and they have defined the interfaces, which is open and standardized. On the management entity and the control plane, they've added few modules into that. For example, the real-time RIC will sit on the control module and non-real-time RIC will sit on the management module, so that we make the 5G RAN more efficient, reliable, and provide the greater user experience. Next slide, Raj. Okay, here we talk about network service. So we are talking about EMBB. We talked about massive machine communication. So what it is? So right, way back from 4G itself, the network functions were virtualized, right? So what we are trying to do is, though it is virtualized, you have a physical box on which it is getting virtualized. So we want to represent this physical box virtually into multiple virtual network. And each virtual network is called a network slice here, right? The combination of virtual components, right from your DU, CU, your core network, okay, everything has to be, virtual network is created over the physical network. And these virtual networks are called slices. And it is one of the key components for the success of the 5G. And each particular network slice, when I proper slice the virtual, the combination of virtual components, a slice will have a different, requirements in terms of throughput, bandwidth, latency, and availability. And the standard bodies has defined network slices for 3, which we have been talking for so long: the EMBB, and the enhanced mobile back broadband, massive machine communication, MMTC, and for ultra low latency communication. And the individual, the deployment guys have come way beyond this. We talk about 3 different network slices to be supported, but they have come around 5 to 6, or even some of them have come with 10 different network slices for that matter.
Anton, sorry to interrupt. Given the paucity of time, I know you have a lot more charts to cover, and Mani has to talk on AI and cybersecurity. If you can quickly run through that, because we probably have 15-20 minutes left.
Sure. Next slide, Raj. Okay, there's a poll question here. So basically, just
Amrita, can you pop up the poll?
So here we talk about just it's a very simple question. So what do you think, in your opinion, the abbreviation of MEC? Yeah, multi-access edge computing, I think 50%, and 36% is mobile edge computing, and 6% managed edge computing, and none of the above is 3%. Okay, so the first one is multi-access edge computing, which is correct. And there are 36% we talk about mobile edge computing. Yeah, it was initially called mobile edge computing, but now they renamed it as multi-access edge computing. Thank you guys for your feedback. Next slide, Raj. Okay, so
Anton, given paucity of time, I think we'll have to really run
I'm
quickly
going
to
to run
MEC
only
because
this.
otherwise.
Yeah,
Thanks.
I'm going to run only this slide, Raj. Okay, so the multi-access edge computing is nothing but bringing the computing. For example, if you want to launch your applications, the end user applications, the enterprise applications, okay, the operator applications. So those will be running on the server farms or the cloud that is very close to the end user, so that the performance of, for example, the gaming application, okay, or the Oracle app or SAP application, or any operator application, for example, the connected cars, all these applications will be running very close to the end user. And as you move across, the applications can be moved to a different edge cloud from where you can access that services. So that's on the MEC. Due to time constraint, I have to wrap it up here. I'll just hand it over to Mani to talk about the security and the AI aspects in the 5G. Thank you, everyone.
Hi, Rajesh, and good evening, participants. I hope you are able to hear me well. So I will walk you through this artificial intelligence and machine learning and the 5G. So I did observe that we can go to the next slide, please. I did see in the chat, in the Q&A, people have asked why 5G and the AI and why it can't be even in the earlier one. The benefit that AI brings to 5G deployment is much more compared to what it can do for 4G and 3G as well, because the overall architecture solution of 5G is designed to give you more throughput and more connectivity, etc. Okay, that is what you're seeing on the left hand side, extreme capacities. But now when I want to give a capacity, for example, sometimes when you're walking and you may be talking on the phone, right? At some places your signal is weak, you are not able to hear the conversation. But if it is a 5G, what happens is the technology uses a concept called beam forming. So can you move to the next slide, and then the next slide, please? One more slide, furthermore slide. No, move forward. Yeah, so that, yes, hold on, thank you very much. So to answer the question how AI is going to help, so I'm just directly jumping into giving you the points, also due to the time factor. So when you are when you are walking and talking, in the current radio network, it just transmits radio waves in a constant form. Whereas in 5G, we have a concept called beam forming. It is the antennas will send a radio wave that is directed to your mobile phone. This is a second bullet point that you're seeing enhanced device experience. So in 5G, when we come up to 5G devices, it will be having the support to handle beams and specific beams. It is like you are putting a torchlight to a particular place where you are able to send the light. Okay. Now, depending on how you can send the data, you can reduce the large amount of data that needs to be sent into the network with a reduced interference, which means if I have to send a data to two users and if they are nearby, you send radio waves or electromagnetic waves. So if you are sending two waves, they will interfere with each other. So if I need to send for two users who are closer by, then I send to one user in a small period, then I send data to the second user in the next period. So we can design this rapidly. You have to do this decision. How rapid is, you have to do this at the level of milliseconds. So when you have to do at such a finer granular period based decisions, you would need something to help you make that decision. How will I send to user one? When will I send to user two? Such cases are done with the help of artificial intelligence and machine learning. Lastly, the last part is radio security, which means today what happens is you turn on the phone, you try to connect to a base station. It can be a malicious base station which can try to make you connect to it and get to know. Whereas in terms of 5G, in the 5G technology, it has a ability such that it will be able to figure out whether this base station is a valid base station or not. How does it do? It has certain characteristics which you call fingerprints. Based on that, it will identify this is the right base station I need to cover. So this is here is just a sample of example how AI will help 5G perspective, and this is from our users. Next slide, please. So here, first one is increasing the air efficiency. So what happens is, now if I are going to send some amount of data, if you can send it in a very short time, right, that is efficient. Whereas if you need a very long time to send, it is not efficient. So how do we bring in efficiency is first part. If you click next, Rajesh, then depending on how the user handset is and to the base station, you will be able to make your transmission in an efficient manner. So there is a question in the chat box talking about batteries getting drained. Actually, it will not happen, because the transformation of the waveform that you are going to transmit, it is chosen in such a way that the amount of energy that you take to send your waveform is actually much reduced. So in fact, it is actually much more counterintuitively a better performing system. So the device power efficiency is being done in 5G. Next point. And then contextual awareness. So where you are, as I said, the beam forming, right? So if you look at, maybe I have a view options. Just give me a, yeah. So now, one of the industrial automation that you saw use case that was asked about. So when you have this robots moving around today, industrial automation, industrial 4.0, industry 4.0 is one of the main application use case coming from 5G support. So in the industries, you have robo to handle certain things, and these are autonomous robots that moves about to perform activity. So now where the robo is, you need to send the data to the robo, which you can do with accurate precision. So this is what initially Raj was talking about, centimeter precision. Next, please. So again, this is where they talked about the AR VR. We don't use AR VR in 5G, whereas using 5G, your AR, VR experience becomes better. So we had some of the participants ask, how can AR, VR used in 5G? Actually, using 5G, you are increasing the AR, VR, which means you see here in the box, there are many antennas, right? And then these antennas are sensing motions. So this antenna is sensing a motion, and based on your motion, you can perform certain activity. So that is what is shown over here. Next, please. And a last part about how this AI helps in 5G is it is enhancing your service quality. And then deployment is very much simplified. Why is deployment simplified? Suppose if I have to, for example, to meet a requirement, should I put 4 base stations, or should I put 3 base stations, or should I put 5 base stations? Take a simple example. A cricket match, IPL, is happening. You are all sitting in the stadium and you're watching your favorite cricketer winning the match, right? Then you saw the ball go, but then you want to see your replay in your mobile phone, which means you need more. You'll be accessing back your Cricinfo or somewhere to see the replay, which means suddenly in the stadium you need more base stations, right? They need to be active. But after the game is over and everybody is gone home, the base station should not be powered on. So how do I simplify my deployment? Means I may have hardware wise enabled, but you will turn them off, you will power them down based on the user demand at that place. So also the use of artificial intelligence in 5G brings in efficiency and security as well. Next slide, please. Next slide. So your entire society, as you initially said, you'll have a much more safer society and a good health, e-health, all that stuff. So as I mentioned, 5G helps to bring all these various unique strengths for your society. Industry 4.0, your industry is very efficient for your automation. Your extended reality related applications can be much more. And then what is 5G V2X side link? See, one of the fundamental part that you would need to understand is in mobile communication, the phone speaks to the tower. And then if you want to, if you're calling your friend, you're calling your mobile phone of the friend, right? Even if your friend is probably just on the other end of the nearby, even if your friend is nearby, for example, you will speak to the tower and then the data will come back to your friend's phone. Whereas you can't talk directly to your friend's phone. This phone and this phone directly doesn't talk. Whereas if you use this concept of side link, the phones can talk to each other. This is very helpful when you're having multiple autonomous cars moving around. They need to coordinate between them. So there is a mechanism designed such a way that the cars can talk to each other without depending on the base station. That is the side link. Then lastly, I'll go to the last point. Millimeter wave is a part of radio wave where large bandwidth is available, and that can help you to bring in more efficiencies. Let's move forward. So we will, there are lots of details. We can share this slide. The thing is, you need a source. Now, how does AI ML work? You have a source, you take some data from that source, how it is behaving now. Then you have some model by which you would have trained. And then you will make the source to behave differently. Simple example, it's a crude example. Most of you might have started learning cycling. When you started learning cycling, for you to get the balance, it would have taken some time for you to figure out how to get the balance. You might have fallen down a few times, but at one point you got how to balance. Similarly here, this artificial intelligence machine learning basically helps how to fine tune a particular device or a source to behave. That is what is an AI ML model is. So that is what is being talked about here. We can skip and go to the upskilling slides directly, Rajesh. We'll skip this. These are details which we wanted to cover. We'll go to the upskilling slides. One part I will talk about on security. Now,
security. Yeah, thanks, buddy.
One point I'll talk about security. Now, the thing is, when you are establishing certain network, it has an option to get disrupted. There are various types of attacks that could be done on the 5G network. So this figure shows you the different types of attacks. You want to stop a service, it is called denial of service attack. And then you can have various types of attacks. Let's move forward. So why does the attack happen? You allow somebody to access your network, or somehow a person enters into your network and creates the issue. So the primary concept of solving such security issue is called a zero trust architecture, which means I'm not going to believe you. Okay, the zero trust architecture is I'm not going to believe you, I'm not going to allow you enter into my network unless you really prove who you are. So that is what the zero trust architecture is. You will have an identifier, which is, now please note, the fundamental difference in 5G is machine based communication. In 4G we have more of still user humans being using, whereas in 5G a machine to machine is going to talk. This machine A will think somebody talking to me is a right machine B. But if machine B has been hacked for some reason, then A will get compromised as well. So machine A has to tell machine B, hello, identify yourself, and then prove with your credential, with your password that you are indeed B. Okay, then you are able to go forward with it. So that is the first part in the zero trust architecture. The second part is any communication should be secure. That's the second part over here, which means you encrypt using cryptographic algorithms. Next slide, please. Then you define certain rules. On what basis will you allow somebody to come? For example, you will not allow everybody to enter into your house, right? You will allow your friend to come, or you will allow your relative to come. So which is a simple rule, which we are not thinking in terms of a rule, but so you have put some rules. So similarly here, who can access it? You have to define the policy rules. That is what this slide talks about. Next slide, please. So the next slide says, now all these are going to be in software. So is this software module a trustable module? On what parameters I can trust this particular software? So you can define the parameters based on which you can trust. So suppose if a person is making queries at some point in time, and this person is, and then you can have a history also that can be taken to evaluate is this a trustable person. So trust evaluation algorithm is the fourth aspect of zero trust architecture. So with this, I think the slides ends. So how do you upskill yourself? Okay, we had a poll question, but we'll skip for the pass of time. So currently, when you take any telecom network, not necessarily 5G, even 4G, you need to say, suppose you're taking a city and I'm going to put a particular technology in it, 3G or a 4G or a 5G. Now 5G, maybe after some time will be 6G. How will I design the rollout of my network will be done by the network architects and network design engineers. So the person who is such has to know what this new technology is. You have to upskill. Then once somebody has designed it, you are going to deploy the network, which means somebody has asked, okay, do I have a cell tower? Do I connect those devices? So you will be a telecom engineer or a network engineer. A telecom engineer, network engineer has to upskill to enable the end-to-end network that will be ready for an optimal design. Now, you may be a coder, you may be a designer to code the solution that goes, like you heard about Bis, Anton saying CUDU, all their stack, which are all software modules. So, or even the data science AI module that you're going to code. So for all this stuff, you need to understand, upskill yourself. What is this CU? What is this DU? And then he also talked about SBA, the service-based architecture. So these are aspects that you are asking questions. So we are trying to give you pointers, but further deeper understanding will help you to make ready for this programming part of it. Now you need to test as well, which right? You develop, you need to do the test. So validation engineers would need to upskill. Now, DevSecOps, development security operation. So how you can in an automated manner develop as well as test it along with security approach. That's the third the other set of engineers. Then today, when you need you bought a new phone, you want a new connection, what do? You walk into a service provider, an Airtel or a Geo, and then say, hey, this is my Aadhaar card, give me a SIM. You put it inside, you get, and then within 2 hours your phone is activated. How does this magic happen? This magic happens because there is a service activation support and maintenance team. So this particular team, service maintenance engineers, technical support engineers, also now need to upskill themselves if they are going to support the 5G network. Next slide, please. So not only this, it is not always engineers who are driving, who are coding, etc. The initial open was done by a great marketing leader, Raj. So marketing leaders also need to know what are the new use cases coming. How do I market this 5G? What is the current people? How much are they willing to pay for a 5G service? What type of service is required? So they also need to understand the 5G benefits, understand the marketing trend, and they have to talk about it. And then I touched upon security. You need, if you are a security professional, how do you design security solutions and implement? Last but not the least, the people who are involved to do business decisions, right? The senior management of an enterprise organization are in the government. Today, Indian government auctioned the spectrum, which means they should understand how the spectrum is going to be utilized. So all of them would need to have this knowledge improved. When we say upskill, means you are increasing your knowledge, making yourself more aware of it. So they also would need to have an upskill on this technology area to make decisions for this. So I think this is my last slide. I hand over it to Raj for the conclusion and closeout.
Thanks, Mani. I think we did run out of time. Some of your questions didn't get answered. We will try and address them going forward. There are some resources we have provided here. In conclusion, I did have 3 more charts, but I would like to leave you with 2 words, which I have learned from NASSCOM, a 38-year-old organization. They talk of co-opetition, which is collaborative competition, which is absolutely a mandate required as the technology evolution is taking place. And we need to have a tashad. What is tashad? Tashad is evolution of technology to make it human-centric. So that is the tashad. So these are the 2 words that I would like to conclude. I'll quickly run you through couple more charts here. When I talk of co-opetition, you see NTT Docomo, the standardization body of LTE standards, they conducted a 6G trial with Nokia, NEC, Fujitsu. This is co-opetition. They're all otherwise competitors out there in the market. This is a classic example, and how NASSCOM has evolved over 38 years is another example. I would have talked of release 18 and advantages, but I guess the expanded side link is a very favorite one for me. And this is how release 15, 16, 17, 18 have evolved. The way to get started is to quit talking and begin doing. Walt Disney, not me. So guys, thank you very much. Apologies that your questions couldn't get answered, but this is where we are. I hope that we were able to provide you some information. Back to you, Amrita.
Thank you so much, Raj, Mani, and Basil. Thank you. It was an amazing session. However, since we had a time crunch and also it was a lot of information packed during this 90 minutes, I will like to tell our people who are joined us right now that we will be sharing a blog with the details of this session and a little more explanation. And please keep tuned to FutureSkills Prime website for other emerging technology information as well. Thank you once again, Mani, Raj, and Atul.
Thanks, Amrita. Thanks to the audience, and appreciate it.
Thank you, audience, for your time. Thank you very much for asking questions.